Welcome everyone. This is the fourth part of the multi-topic text classification with various deep learning models tutorial. You might remember that in the first three parts, we have already covered the basics of text classification, and then we talk about the data set that we are going to use throughout these tutorials. And in the last part, we have just prepared the data set. In this fourth part, part D, we are gonna pre-process the text by using TensorFlow data pipeline and Keras text vectorization. Before delving into today's topic, I would like to introduce my channel briefly. At the Murat Karakay Academy YouTube channel, I share tutorials with source codes in English and in Turkish about artificial intelligence, especially how to implement deep learning and machine learning approaches with Python using scikit-learn, TensorFlow, and Keras libraries. If you are interested in artificial intelligence, deep learning, or machine learning, and if you are looking for theoretical and practical information, please subscribe to my channel and activate notifications. When you subscribe to the channel and activate the notifications, you will be notified of live broadcasts and newly uploaded content. Now, let's continue with today's topic. Okay, before getting into the details of today's tutorial, I would like to mention you that that's a live broadcasting. So if you have any questions, you can ask your questions throughout the chat screen, and I would like to answer your questions immediately. All right. Now, in part D, we are going to talk about how to pre-process text by using TensorFlow data pipeline and Keras text vectorization layer. I hope that you know a little bit about TensorFlow data pipeline API, but if you don't know TensorFlow data pipeline, you need to go over some tutorials that I prepared for you. These are in English and in Turkish. You can find them on Murat Karakay Academy YouTube playlist. Here I shared the playlist links. Also, you can visit the Medium blog if you would like to read the content of these tutorials. But whatever, you can just follow me in the tutorial if you don't have any idea about the TensorFlow data pipeline, because I will try to explain the necessary information throughout this tutorial. But if you like to learn the details and how to implement the TensorFlow data pipeline with different data sets, you can check these tutorials as well. Before beginning the building the trained TensorFlow data set, I would like to remind you that in the very first three parts, we already prepared a trained feature data frame. In that data frame, as you see that we have some comments, some reviews, some complaints about some services. So here you see that these are the 5 example statements or comments or reviews. They are in Turkish, but it doesn't make any difference how we are gonna pre-process text data with Keras or TensorFlow. And here you see that we have the train targets data frame. In that data frame, we have the topics encoded as integers. To train any deep learning model for text classification, first we need to supply an input, and the model will decide its category. Therefore, to train such a model, we are gonna first prepare a train data frame with 2 inputs, actually 1 input for the text or reviews, the second output of that text in terms of categories. Therefore, I will use TensorFlow data API dataset class from tensor slices function. This function will convert a data frame by using the given TensorFlow data type and create a data set for us. So data set is a special data structure for TensorFlow and Keras. Now we created this trained text dataset row, and similarly we can create the categorical dataset which will show us the output of the text, the category, the topic or class of the text, by using the same function to convert the data frame values into TensorFlow integer 64 data structure. After that, we need to decide the dictionary size and the review size. These are two important parameters for a text preprocessing. As you know that we cannot supply text directly to a deep learning model. We need to encode the text in some formats. This is mostly a vector format. In that vector, the content could be different, but the representation of that content mostly or always some numbers. And we need to convert the text into these numbers. To convert the text, especially if you are talking about the tokens as words, we need to create a dictionary. So this dictionary will hold the different number of text tokens like the words and their corresponding indices. By using the dictionary, we can encode the text using some integers or the index values of these tokens. Therefore, I would like to remind you that in part B, we have witnessed that 75% of all the reviews are less than 50 words. Thus, we can I actually selected maximum length of the reviews as the maximum review size of 50 words. Okay, so it means that if some reviews are less than 50 words, we are going to use some padding methods, adding some space into the text to make the review size 50 words or 50 tokens. If the review size are larger than 50 tokens, then we are gonna cut off these reviews and we will make all the reviews the same length, 50 tokens or 50 words. For the vocabulary size, remember that in the first three parts, we have witnessed that there are more than 400 keywords, different keywords. So that's too much. What we decided is that we can limit the different words with 100k. So to create the vocabulary size, we decided that for the moment 100k is enough. So after deciding these two important parameters, we can use these values to create these two important variables, the vocabulary size and max length. We are going to use these two important parameters when we are going to set up our text vectorization layer, and we are going to see in a moment. Okay, why we are going to use text vectorization layer, Keras text vectorization layer? First of all, I would like to mention that Keras preprocessing layers are very useful when you develop an end-to-end model. So there are many different preprocessing layers provided by the Keras. The important thing is that these are native layers. So you can use these layers inside a deep learning model. When you compile this model and when you train this model, you can easily deploy this model in any environment virtually. So you don't need to stay in the Python environment. You can just deploy this model into, for example, JavaScript environment or Android environment easily. Since you just embed these preprocessing layers into the model, in that new environment, in that new platforms, you can just supply the raw data to that models, and the preprocessing layers will just transform the raw data in a format that your model will calculate the weights and biases. So that's very important if you would like to create a truly end-to-end model. And I strongly suggest use Keras preprocessing layers. Therefore, instead of using Python preprocessing functions, here I will show you how to implement and use text vectorization layer, Keras text vectorization layer, in a deep learning model, especially in a TensorFlow data pipeline. But if you are not accustomed to text vectorization layer, and if you would like to learn the details of it, how to use it, how to set it up, I have already prepared a 4-part tutorial series in English and in Turkish, and you can access these links from the Colab notebook. Alright. To preprocess a text, we need to make it first turn it into a standard format. So what I mean is standard format or to standardization, we convert the text without losing its content into a standard format. For example, you can convert all the upper cases to lower cases, or you can remove unnecessary symbols such as stars, such as punctuations, or you can remove some HTML tags, or you can remove some repeated text. You believe that these words don't contribute to your text classification model. Here you see that I already prepared these transformations by using TensorFlow strings class or library. Why I use TensorFlow strings library instead of Python string library? Because, as you might notice already, here I use TensorFlow decorator, function decorator. So I already announced that this function, custom standardization function, will be serialized in Keras environment, because I will use this custom standardization function inside the Keras text vectorization layer in a moment. So that's an important note for you. I am creating a function to be used in a Keras layer. Therefore, here inside that function, I use all the necessary functions from TensorFlow libraries instead of Python libraries. It will help me a lot and prevents a lot of possible problems when I implement these classes by using Python libraries. Here, I would like this wrap up. That function, custom standardization function, will be used in Keras text vectorization layer. Therefore, I just use a TensorFlow decorator to decorate this function as a serializable function, and that in that function I use from TensorFlow libraries functions. And then I just replace some symbols, some text into different symbols, or remove these symbols. And here you might notice that I also remove the extra spaces, if any. And then here I just replace the Turkish letters with English letters. At the end, I just return the standardized text. Now, let me check that if this function works correctly. So here is my Turkish input statement. I use that function to convert this input to an output string, and I print out the output string. Here you see that the input string and the output string, and you can verify that this function works properly by removing or transforming the input to the output as I wish. So it removes, for example, stars, numbers, punctuations, capital letters to lower case letters, etc. Now, since I prepare my custom standardization function, now I can begin with text vectorization layer. Please keep in mind that text vectorization layer is a Keras preprocessing layer, such as input layer or dance layer or LSTM layer. It's just a layer, a Keras layer. So as in every Keras layer, we have some properties or arguments. Here the standardized argument requires us to provide a function so that the text vectorization layer will apply this custom standardization function onto the given text. We already prepared this function, so I provided this function as an argument parameter to the standardized parameter. Now the second parameter is max tokens. So it determines the vocabulary size. So I provide the vocabulary size. And the third important parameter is output mode. The text vectorization layer inputs a text and converts this text into some vectorization or vector format. Provides a vector format for the given text. But there are different kinds of vectors that it can generate. These are using TF-IDF value of the tokens, or using the vocabularies index value as integer, or binary or count values. I will not go into details of these four modes, but I would suggest you to go over the tutorials that I have already shared with you. Here I will use the integer output. Why? Because it's very easy to understand and very frequently used, very popular method. In that method, I suggest or I request the text vectorization layer to convert the given text into the integer vectors. These integer will come from the dictionary indices. I will show you an example in a moment. The fourth and the last important parameter is output sequence length. It determines what would be the output maximum length. Actually, it's not the maximum length, but it's the fixed length. I mean that when we provide the max length to that parameter, all the outputs will have the fixed length equal to max length. If the input text is less than the max length, the text vectorization layer padded with spaces that input. If the input is larger than the max length, then the input will be truncated as the max length. The output will be equal to the max length. So whatever the input size is, the output will always be the length of max length. So that will help us to create the fixed length of input to our model. Now I can show you some examples in a moment, but before that, after defining the text vectorization layer with its parameters, now we need to apply this layer onto some data. Okay, here it's really important thing that I am not going to adapt text vectorization layer on whole data set. Instead, I will use only train text to adapt the text vectorization layer. As you might remember that in the previous parts, I explained the reason very well. I would like to prevent any data leakage. Here, the adapt method of the Keras text vectorization layer will take care of all the text in the train text dataset row and will create a dictionary. Here you see that by using the get vocabulary function, I can get the vocabulary from that layer. Let me show you what is a vocabulary. Here you see that we can get the length of the vocabulary and we can get the first 10 input of that vocabulary, and we can just use the vectorized layer to convert these inputs and tokenize it and transform it. Let me show you in detail. Here you see that our vocabulary has almost 60k entries. But you might remember that I just set up the dictionary size 100k. You might remember here. Remember 100k. But when I adapt text vectorization layer on the train data, it ends up with finding 60k different words. Why? Because you might remember from the last part, I used some part of the train data to save memory and the time, training time. So there aren't 100k different words, but there are only 60 different entries, 60k different entries. Let's check the first 10 entries in the dictionary. 0 represents the null value or space you can think of. 1 indices stands for unknown words. 2 stands for the most frequent word in the train data, which is bir, in Turkish 1. The second most frequent one is in Turkish ve, in English and. The third most frequent word is bu, in English this. So these are the indices for the frequent words, and actually for each 60k entries we have some index number. So by applying text vectorization layer, which we name vectorized layer here, remember, we name this vectorized layer. Okay. By adapting vectorized layer onto train dataset, we already created a dictionary like that. Okay. And by using this dictionary, we already tokenize the text, standardize it, and create the dictionary. And by using this vectorized layer, I can transform the text into a vector of integers. Let me show you. Here, this is a given text in Turkish. And then, after tokenization, standardization, and transformed, we have a TensorFlow tensor. And here are the integer vector, which has a shape of 1 and 40, I am sorry. The 40 shows that there are 40 integer numbers. Each corresponds a word in a dictionary. Here you see that 3, remember that 3 represents ve in Turkish. Here is ve, so it's converted 3 here. So basically this layer, vectorized layer, will input some text and convert it to a tensor shape of 140, as you see here, and we have convert any text, tokenize, transform, standardize, any text like that. If the text is short, then we will see at the end 000. Why? Because remember that 0 means that null values. But all the output will be 140 shape. As a bonus, I would like to mention how to save and load an adapted text vectorization layer. Why? Because adapting text vectorization layer on a text dataset actually takes considerable time. So when you try your model, you don't want to each time adapt text vectorization to your raw text. Instead, you can adapt once and you can save these text vectorization layer, I mean the tokenization, standardization, and transformation properties of that layer, and then upload it and use it. Here I will show how to do it very simple terms. Actually, you can create a sequential model. Then as a layer, you can add this adapted vectorized layer and then save that model as you see. Then you can load this model by using Keras models load model function, and then you can just use the layer that you saved as you see here. Then you can use in your model in the deep learning classification text classification model. Here I show you that you can be ensured, or you can ensure that the loaded model, the original, the loaded vocabulary are all the same. Here you see that the entry numbers are the same for the original dictionary and the loaded vectorized layer. Okay, here I provided more examples to check that if the original vectorized layer, the loaded vectorized layer, or the loaded vectorized model create the same transformation, tokenization, and standardization. Here you see that for one text, they all create the same output. So you can safely use this method to save your adapted model. Okay. Let me check that if there is any questions in the live comments. Unfortunately, we don't have any questions. I wish you could ask questions during the live broadcasting so I can answer you immediately. Okay, let's continue. After creating or after adapting the text vectorization layer, now we only have the dictionary, but we didn't convert, transform, tokenize, standardize the text in the train, validation, and test datasets. Let's do it. To do this, I need to create another function. This function will take some text and apply the vectorized layer, which is already adapted to the train dataset, and convert it as a TensorFlow tensor. To apply this function onto train text dataset, I will use the map function of the TensorFlow data API. So I am now using TensorFlow data pipeline. By providing the function, so I am suggesting that the map function will use this function to transform every element in the train text dataset row. Here, the important thing to know is that I use the non-parallel calls. Therefore, thus the TensorFlow will help me to apply this function onto every element of this dataset, running it on a parallel processing. That's very important because otherwise it will take a lot of time to apply this function on every element of trained raw dataset. If you use Python code for that, it would take more time. But if you use the TensorFlow Data API, as I did here, it will save you a lot of time and pre-processing or processing time. Okay. At the end, I will have trained text dataset. It is not a raw dataset anymore. In that dataset, the texts are converted into integer vectors. All right. And let me show that in that trained text dataset, the inputs are not the words, strings anymore, but they are the converted, transformed, standardized integers coming from the dictionary. Now, as we already discussed, our trained dataset will have two columns. First tuple or a tuple. The first of the tuple is the trained text dataset, which is actually the review in integer vector format. The second one is the topic of that input. Okay. When I zip them by using again TensorFlow Data API dataset library, I can zip them and now I have the trained dataset. I apply this trained dataset as an input to any Keras deep learning or TensorFlow deep learning model. Okay. Let me show you an example. So if I get one example, the first one from the trained dataset, X and Y, then I can show you that X is a TensorFlow tensor with 40 integers and the Y is an TensorFlow tensor as the type of integer and 28. So 28 actually is the sports in Turkish in the topic, and if you convert this to the text, you would see that text in Turkish. So how can I do this? Actually, I use the vocabulary to convert the indices to just the text or the words, corresponding words. And remember that in the third part, I already created the ID2 category dictionary. By supplying the topic number, I can get the category text. So that's I already prepared for that reason. If you check the train size cardinality, you see that there are 15K samples in the train data set. What we are gonna do from now on, we need to prepare the validation data and the test data as what we did in above. So first we need to use the TensorFlow Data API to create a data set. Remember that data set is a TensorFlow data structure, a special data structure. So by using the from tensor slices, you can create that data set. And similarly for the categorical data set, so the categories, the topics are converted. And then we need to apply or map the prepare language model inputs labels, which will apply the text vectorization layer onto the text. And then we already prepared validation text dataset. Then we can put these two datasets together as one validation data set. Similarly, you can create the test dataset. You can create the datasets first, these two, and then apply the prepare language model input labels by applying the actual tensor Keras text vectorization layer, and then we can zip these two to create the test data set. If we check the, for example, test data set, taking one and the first sample, you see that we have two, in the tuple we have the two things. The first one is x with the shape of 40 integers, and the y is only one integer. So in the x you see that we have 40 integers. Each of them corresponds a word, a token in the dictionary. And y is just one integer which corresponds to a topic. So let me convert all of them into text, the x and the y into a topic. Okay. Now we can finalize the TensorFlow data pipeline. TensorFlow Data API provides you many important facilities to help you in training, especially. Here you see that in training we use the batch size, so here you can define the batch size. And also TensorFlow Data API helps you to decide some auto-tune parameters depending on your hardware. Here, as always, please shuffle your data. The data TensorFlow Data API helps you to shuffle data. Then here you see that we can batch the data, and here you see that there is the cache function. By commanding the TensorFlow data pipeline cache, it will cache you the data. It will help you especially to accelerate your training data. Moreover, it will provide you the prefetching the data. This is very important. When you train your model, most of the time your training will take place in the GPU. This time the CPU will free. So the TensorFlow data pipeline, by using the prefetch method, you just command that TensorFlow data pipeline will take care of uploading the next batch while you are training your model with the current batch. So actually it will help you a lot. With cache, you will upload the whole data set in the first epoch, and then in the prefetch, for each step it will upload the other batches. So you will experience that your model in training will be accelerated a lot of. So I strongly suggest you TensorFlow data pipeline instead of the data generators to accelerate your training. I am going to do the same settings configuration for the validation and test data. At the end, you can check these batches. Now you see that we have 64 batches of 40 integers. So, and we have also 64 integers as topic. So we are sure that we split the data into batches with size of 64. All right. So you here see some examples. Let me check that if any questions. Unfortunately, we don't have any questions yet. So after the broadcasting, if you have any questions or comments, please share into the comment section. I would like to answer your questions and appreciate your comments. Okay, now we can summarize what we learned so far. We actually create a TensorFlow data pipeline. Then we configured a Keras text vectorization. Then by using this text vectorization layer, we adapted it to the train dataset. Then we apply these layer to train, validation and test datasets. Then combine all these datasets, configure TensorFlow data pipeline to use in any Keras TensorFlow deep learning model. So in the next part, we will use these three datasets to train and test a deep learning model. I hope that you find this tutorial useful. If it is so, please click the like button. Please subscribe to my channel. I really appreciate it. Before closing the session, there is one comment, I believe. Let's see. There is a question. What is auto-tune? What is used for? It's a good question. Let me explain it. To configure your TensorFlow data pipeline, for example, in the prefetch, you need to configure what would be the batch size, what would be the cache size, what would be the timing of the prefetching of the next batch. So actually you need to provide some parameters to the TensorFlow data pipeline to synchronize the training of the GPU and the CPU prefetching. But most of the time, if you are not well educated on this and if you are not don't know your hardware, you cannot provide the correct parameter values for that function. Therefore, TensorFlow data API helps us by providing a auto-tune function. Actually, auto-tune looks and understands, examines your your hardware and tries to find the optimized parameter values for you. So instead of here providing some values by hand manually by assuming some values, you just depend on the TensorFlow data API to decide these parameters for you. That's why we are using auto-tune. I hope that explains why I use the auto-tune here. Any other questions? Okay, thank you for the question, Saket Ingar. If there are no more questions, I could finish the broadcasting right now. We will continue with the next episode by creating a new a new deep learning model, and then we will follow 4 different or 5 different models by using these 3 data sets. Here there is another question. So auto-tune will take care of hidden parameters for uninterrupted execution of code. Am I right? Yes, you are already right. But I would like to clarify again that auto-tune is used here in prefetch function. Okay, so in prefetch function, you need to set up some arguments. So but instead of you provide some values, you can use the auto-tune to decide the parameter values. Yes, you are right. Okay, so I will finish this tutorial here. Thank you for your participation and thank you for your questions. If you have any questions, any comments, please write it to the comments section. And I hope to see you in the next part. Take care. Bye bye. Bye bye.